We're going to need this handout here. It should be in this week's folder. So you may want to take it and download it to your computer so you can kind of take a look at it as we go through the problem, called Introduction to Simple Linear Regression. So I'm just going to show it to you now here, but I'm going to remove it. So everybody make sure you have that. And it should be under something that says handouts on regression or something like that. So we're going to work through this one here. So we have those 4 stores there. I don't know what chain it is. I don't know, Victoria's Secret, I don't know, whatever it is. But notice how we have the store branch, and you see how for every store branch you have 2 pieces of information. You have the foot traffic and the sales. All right. Now, so 29, that means, I guess that's how many people enter your store between 1 and 2, 29 people. And in that same time period, you got $312. Okay, so that's the general kind of setup. So look at number 1. This goes back to our discussion earlier. Which of the variables is the independent / explanatory variable, and which one is the dependent / response variable? Anybody have any idea about that? Which one would be independent?
The foot traffic would be independent, correct?
Let's see, the foot traffic. Okay, why?
Because without those people coming into the store, you wouldn't produce those sales.
Okay, all right, very good. At least the sales is not online or whatever, right? Okay, so yeah, so everybody can go ahead and answer that one. Because generally in a problem like this, I probably would tell you which one is which, but just in case I don't, like suppose foot traffic and sales columns were switched in terms of location. What if sales came first and foot traffic came second? Then you would still have to know which one of those makes sense to be an explanatory and which one would be the response. But generally in a problem, I'll just go ahead and give you that, right? And it's going to be important later when we are solving the problem that we know which is which. So now let's draw this scatter plot. And it's important for us, and as a matter of fact, let's go ahead and write the definition of scatter plot. So we're going to go through the steps of how to figure out what this line of best fit is. So we'll say how to arrive at the regression line. How to arrive at the regression line, in a sense. And I'm just going to go through all the steps here. So make sure on a problem, you sort of go through these steps. So how to arrive at the regression line. So this regression line is going to be what we call the line of best fit, and we'll see why in a second. So let's say step 1. Step 1. Let's say draw the scatter plot. SCATTERPLOT. Draw the scatter plot. So that's essentially, you have these, like you drawn a coordinate plane, right? And most of the time, most of the action is going to go on in the first quadrant anyway. You may go down here depending on what X is, but it's really important for us to know, for example, which column is the X and which column is the Y, because along the X-axis here, I'm going to write this X here, that's where we're going to put information on the explanatory variable, explanatory or independent variable here on the X, and then this right here, Y, which is going to be the response. See, that's why it's important for you to know which is which in terms of explanatory or response, because I have to make sure that I don't end up putting response on the X and then explanatory on the Y. It's got to go this way and that way. Now look at our data. And what we're going to do, so for the first store, it says 29 and 312. See, we have this 29 here, and we have this 312. So what I want to do is treat this as a coordinate plane, X comma Y, right? And if the X's are here and the Y's are here, I need to figure out, now let's look at the range, let's see our X values. I'm going to look at all the X values, 29, 49, 110, 31, then the sales, 312, 500, 799, 102. So looking at those ranges is going to help me figure out how to put the values on the X-axis so that they're spaced out pretty well. So I don't know, it's not drawn to scale. let's go up on the x's by, let's say, oh, I don't know, by 25s, by 25s. Okay, so it's really rough. We don't have graph paper, and that's okay. Let's just say 25, 50, 75, 100, and 125. The only thing I'm doing is looking at the x columns and seeing what's the low number and the high number, and then try to plot here accordingly. Now let's look at the y. Let's look at the y. The values here are 312, 500. Okay, so I'm going to go up by, oh, wow, we got to go up 7. So let's go up by 200s. You can choose whichever way you want to go up. There's nothing magical about 200s, but you know, you don't want to go up like $1 at a time, you know, and those would just look crazy. So let's say 200, 400, 600, yes.
What does it say next to y?
Oh, response.
Okay.
So that's the response variable. Then down here it says explanatory right here. Okay, so now let's start plotting these points. So treat this as an XY coordinate. So I'm going to plot 29, 312. So 29 roughly is here. Oh, I don't know. And then we try to do another color. No, this is fine. 29 and 312. So roughly around here. I don't know. So that's the first store. So this dot represents 29, 312. Now go ahead and finish plotting the rest of these. 49, 500. 49, 500. Somewhere here. I don't know. 110. 799. 110. 799. That's almost up here somewhere. And finally, 31. Roughly here, and 102. 31 and 102. Okay, again, we don't have graph paper. Do the best you can do. Just kind of get those out. But see how here, each one of these dots represents a store, right? Foot traffic, money. Foot traffic, money. So, you know, I'm not going to all of these, but this in a sense would be 29, 312, like this point right here. Now, what regression says, and so this is step 1. This is the scatter plot. So this answers number 2 on the handout. A scatter plot is simply a pictorial representation of the data, right? So this is the data in picture form. That's all that's saying, right? And you can see here, I can put an imaginary green line on here. You see how now we have more than just 2 points, how we had before the break. We have 1, 2, 3, 4 points here now, all right? So when we have these 4 points, I need to figure out where do I draw this green line, this imaginary green line, in a place that summarizes the location of these 4 points the best. For example, don't write this, don't draw this. What if I drew this line right here? Okay, is that the best line to fit? Is it close? Is it as close to all points at the same time as any other line that I would draw? And the answer would be no. You see how far away it is now? I'm going to think about vertical distance to that line. Look at this point. You see how far away these points are to this line here? If I would sort of draw the vertical distance, right? Well, how about this one? How about this one? So don't draw this green right now. Well, I don't know. Let me guess. How about this one? Is that close to all 4 of these points at the same time? And the answer is no, right? So the whole point in going through what we get ready to go through is that doing this mathematics that we get ready to do is going to help us find the equation of the regression line that's going to fit snugly with all those points, probably some points above it, some points below, right? But we're going to try to find the green line that's going to be as close to these 4 points as possible than when compared to any other green line that I would draw. Okay, so that's the whole notion of the line of best fit. Now, in order to do that, we need to, if I draw any green line, that green line is going to have an equation attached to it, y equals mx plus b, as all lines do, right? What I want to do now is when I find the slope, I've got to use each one of these 4 points to help me find the slope, and each one of these points to help me find the y-intercept. Yes, all right? So that's what we're going to focus our attention. Step 2. Now, hold on to your drawing. We got to come back to this, but I'm going to have to erase mine. I got to erase mine. So let's say step 2. Let's say step 2. Calculate the slope. I'm going to say m in parentheses, and the y-intercept, which is b, for the regression line. Yes.
So would this go towards number 2 still, or number 3 in the problem?
Yeah, so it's step 2. I don't know what the actual problem numbers are, but these step numbers here may not coincide with what's on the handout.
I mean, it kind of does. Number 2 says draw the scatter plot for the represented data. And then number 3 says what is the slope of the regression line? What is its interpretation in the context of the problem?
Okay, yeah. So I guess when we do these right here, it's probably going to coincide with 3 and 4 in the handout, I think.
Yeah, because 4 is asking what is the y-intercept.
Okay, good. Yeah, but the numbering there just may happen to coincide with these steps, because when we do this right here, it's only going to be 3 steps total.
Okay, thank you.
All right. So now let's calculate the slope, and I'm going to, if you look on page, let's see, look on page 303. Look on page 303. Page 303. And things are going to be slightly different. Yes.
Sorry, it's just not like, it's a little blurry. Can you please read what you wrote? Calculate the slope.
Oh, yeah. Yeah, calculate the slope, and then I put an M here. And the y-intercept, which is B, for the regression line. I left off line. For the regression line. Okay. Now, if you look on page 303, it's a little different in this book, because you see at the very, very top of the page, it says to calculate the regression line, and they have y equals a plus b. This is going to be a little confusing because we're saying y equals mx plus b, or y equals b plus mx in a sense. So these two formulas I'm going to show you here, the first one, you see where it says a equals that? For us, that's going to be our y-intercept. So in my textbook, I crossed out the A and put the letter B there for y-intercept. And then scroll down a little bit, you'll see the other formula that says N and then some other stuff. They have B there, but that's going to be our, so that's going to be our M. But I'm going to write it on the board so we can figure out what this means. The formula for M looks like this. M equals, here's an N, here's the summation symbol, and we're going to talk about what that means. XY minus summation symbol again, X, summation symbol again, Y, all over. So now this is not an E, this is a summation symbol. On the bottom we have N summation X squared minus parentheses summation X squared. Okay, so you can write that down. Because see, remember what the goal is? The goal is for us to get something, a regression line equation, which looks like y equals mx plus b. But we've got to go through more drama before we can come up with this m, and also come up with this b right here. So I'm going to write them up for b, and we're going to see how we deal with this with our data. Summation of y, summation of x squared, minus summation of x, summation of xy, all over the same denominator right here, n. So just write the same denominator right there all over again. So don't let this scare you. because you're going to see it's going to be very straightforward as we need to solve for it. In other words,
sorry. For the B, the last part, is that summation xy?
Yeah, this right here, summation xy right here, yes.
Okay.
Yes. Yeah. Remember where we're trying to go? We're trying to get to y. I'm going to write this L right here, and I'll explain what that means in a second. So this right here.
Professor?
Yes. Yes.
I'm sorry, the screen's just a little bit blurry. Would you mind repeating the formula for B again so I can copy it down?
Do you have the book? Do you have the book handy?
I do.
Or no? Because it's the same thing on page 303, and in case you can't really see it here. So the this formula right here, this M, is the second formula in the middle of the page 303. See there where it says N summation XY, blah, 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 blah. And then the top one is this B over here where it starts with summation of Y. And then over that same denominator.
I see it in the book now. Thank you.
Okay, all right, yeah. Yeah, my handwriting may not be as good here. So we're trying to get
step 3.
I'm sorry?
Is that step 3 or are we still in step 2?
All of this we're doing is all of this is step 2.
Okay.
All of this is step 2. Yeah. So we're trying to get to y sub L equals mx plus b. We got to calculate this m, calculate this b. The only reason I put an L right here is because this is going to be considered a prediction line, right? So this L just means linear prediction. Sometimes you may see it like with a hat on top, right? It's the same thing. So now let's solve for this slope here in the equation. And what you're going to need is your original data from the handout. So look at the handout and look at the data for foot traffic and sales. Now, this N here, I'm going to write this in. This N here represents how many stores or how many observations or how many subjects we have in our study. So how many stores or how many pieces of data do we have in terms of, in this particular problem, like how many stores do we have here?
4.
Okay, 4. So be careful that you don't say N is 8. That's a temptation, right? It's not how many different pieces you have, it's just like how many stores. Now each store has 2 pieces of information, right? So we have that N equals 4. Let's look at summation. I'm going to skip this one right quick. I'm going to do summation of X. And you're going to need your calculators on this. So if I go to the X column, which is foot traffic, remember that's the X, that's our explanatory, right? So what this says here is to do what? Add up all of the values in the X column. So add up all of the foot traffic and let me know what you get. 219?
Yeah.
Okay. So I added up everything in the X. So as I finish them, I'm going to kind of circle them. So we did that. We got this. So N is also going to be 4 on the bottom. We found that. Now, summation of Y is what? You're going to go to the Y column. In this case, Y is sales. So add up all of, this says summation, add up everything in the Y column and let me know what you get. Well, 312 plus what else? So what the other 4, and let me know what you get on that. Okay, 1713. All right, so this one. And also over here, I'm going to circle. So we're going to sort of do these at the same time. We got that. We just found that. We found this over here. So you see what we're doing? We're sort of going bit by bit, and then we're going to go back and actually solve it. Let's go to this right here. Summation of, no. Yeah, this fine. Summation of XY. Let's talk about summation of XY. We're going to see what this equals. Now, you see 2 things going on here. You see adding, and what's the operation between X and Y? You can't really see it, but what do you assume is the operation between X and Y? Is it also adding? Yeah, good, actually multiplication, right? So what this says plus and then summation. Now PEMDAS, or operation. Which one do I do first? Do I do addition or multiplication first? Just in general. Just in general.
Multiplication.
You do multiplication first, right? So here's what's going on here. Look at your data. Well, what was it first? I think it was 20. Oh goodness, I can't remember. I'm trying to do all this stuff from memory. Okay, 29 and 312. So we have 29, 312. Then we have 49, 500, blah, 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 blah. So what this says is this. Here's the X, here's the Y. I don't know, you tell me. How do you interpret this in light of that data? It says multiply, you have multiplication, and then you have this addition. How do you think we will find, how do you interpret this in light of that data right there? There's the X, there's the Y. Apparently, I'm going to say X times Y first. This times this equals something. This times this equals something. So you're going to multiply first, and then the final result, I'm going to add these numbers right there. Okay? So I'm going to say this times this, this times this, this times this, this times this. I'm going to get 4 thises, and then just add those products. So that's the summation of X times Y. So let me know what you guys get when you go there. Wonder what your final result is. This times that, this times that, this times that, this times that, and then add them all together. And if 2 people get the same answer, I'm going to assume that they're correct. So move on. Okay, I see 1 number. We'll see if anybody gets the same thing. Oh, okay, you got the same thing? Okay, all right. So that's 124600. 124600. Again, this times that, that times that, this times that, that times that, then add them all together. Okay, see, multiplication comes first. Multiplication comes first. All right, so that's this one. Then over here, that's this one. That's that one. We got 2 things left to find. 2 things left to find. This says summation of x squared. This says summation of x squared. Oh, I wonder if they're the same number. I wonder if they're the same number. Can anybody think they know how to explain, even before we get into the math, can anybody look at those 2 things and tell me if they're the same or different? And if they're different, how would you explain how to find them? What's the difference? Or is there a difference? Look really carefully. Look really carefully. Who is this? I don't know. Is it Michael, Talia? Which one of you?
Talia, I just raised my hand.
Okay.
I think they're different because the square is outside the parentheses on one. Does it apply to the whole thing in the parentheses, whereas the other one is just on the X?
Okay. So then this one here, how would we find this answer right here? What is this saying to do?
Multiply the summation and I don't know.
Okay, we're getting there. But yeah, you are right that they are different conceptually. Because anybody want to try to explain what's going on right here? Like, how do we get that? Cameron, what's going on there?
Would you just square the 219 that you previously got?
Oh, because, okay, so this parentheses is saying add them first. I guess please excuse. So the parentheses is like first. So yeah, so this is saying focus on adding them first, and then whatever answer you get right here, square it. So you're exactly right. I'm going to take this 219. So this is summation of x, whatever that is, and then square that answer. So essentially that's going to be 219 times 219, or 219 squared. So everybody find that. What is that? 219. You can either multiply it by itself or just raise it to the second power. Okay, I'm getting 47961. Did you guys get that? 47961. So that's this one, and that's this one. Very good.
Wait,
Almost
did
done.
you verify? I'm sorry.
I'm sorry, what side?
I
I'm sorry.
didn't hear you. What number did you square to get the 47961?
The summation of x, which we found earlier to be this value right here.
Okay. So 219 squared.
Yeah. So this is add up the x's first, which is right here, and then just square that number. So essentially, this is 219 squared.
Okay.
Who else? Joya, you got a.
Yeah, hi. I'm a little bit confused how you even got the 219 from the summation of x and the 1713.
Okay, so the 219 comes from adding up everything in the x column in the original data that was given in the problem. You see
Okay.
that? 29 plus 9 plus whatever's in the x column. And then the 1713 comes from adding up everything in the y column. 312 plus 5.
Okay.
Yeah, those there.
Thank you.
All right, now let's look at this right here. Can anybody explain this one? This is the only thing we have left over. See, we did this one by saying 219 squared. And how are we going to get this one right here? What does that mean?
Would you square each x and then add the result of each one together?
Yeah, okay, so this says, yeah, you see how you have summation of x squared? So there's no parentheses around here, which tells me what I'm going to have to do is square each of the x's and then add. See that? Square through the x's. So here's my x column right here. 29, 49, blah, 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 blah. So x squared column would be 29 squared. What is 29 squared? 841. See that? So what I'm doing is squaring each of the x's first, and then once I get all of these, then I add. Okay? So go through and find those. 29 squared, 49 squared, 2401. Then keep going, keep going. So once you get these four values, then you add them together, then that will be here. Let me know what you guys get once you, okay, so we have one answer. Okay, we got two. All right, so 16,303. So we have to get these different components. So we got that. We got that. So we found all the different components. So I want to make sure everybody's able to get that 16,303 there. But remember what we did. And in your notes, you're going to have to say something to remind yourself how you got these values, right? So we just square, and add them together, then we should get that number here. So these are the different components. So what I'd like for you to do now, we're still on step 2. We get different values, so what we need to do now is put them inside of here and figure out what our M is. So M is this. M equals, look at the formula here. N, so what is N? It's 4 times summation xy. So you have your different values here. 1, 2, 4. 600. See? Minus, what is summation of x? 219. What is summation of y? 1713. All over n4. Summation of x squared we found to be 16303 minus this thing right here we found to be 47961. Okay? So these are just the different components. So if you're going to go wrong, if you are getting any one of these components wrong, it's going to affect your answer for n. Now, when you're solving for this, you find this part first, 4 times that, then say this times that, then subtract those. In other words, I'm assuming you guys know how to find this part right here. This is regular like algebra. Multiply these, multiply those, then subtract. Then here, multiply that, subtract that, and then your final situation, say this divided by that. And let me know what you guys get for n. And I guess 2 decimal places would be good if it comes down to decimals. Yes?
Professor, to get the EX in the parentheses with the squared outside of it, I think I missed how you got that.
This right here?
Yeah.
Okay, so this right here says take the sum of the x's, and once you add all the x's, you square it. So essentially, it's the squaring of this number right here, because when you take the summation of x, you add all the things in the x column, it's this number, then you square it, and you get this number right here.
Okay, thank you.
Okay, so let's see. So it seems like a lot of people getting the same thing, right? 7, let's see, looks like people are getting 7.14-ish. If you had to round off, would it be 7.1? Okay, yeah, 7.14. Yeah, take 2 decimals. So what you want to do, you should be able to put this whole thing in a calculator, right? But if not, don't feel bad if you have to say, whatever the answer is there, you write it separately. That answer, write it separately. That answer, write it separately. But I'm going to assume this is a pretty simple lesson in your calculator. If you get stumped on this part, just set up office hours with me, and we can sort of go over how to do it. But at least right now what the answer is. Go ahead and do B. Go ahead and do B. And the good thing about B is that the numbers in the denominator are going to be the exact same. So whatever number you came up right here when you're solving it, just use that same number when you're solving for B. So the only work you got to really do is the numerator part there. But I'm going to go ahead and put in the numbers so you can at least see what's going on. Summation of y, 1713.
Professor?
Yes.
I'm just a little confused because in the book, like, what is the, because in the book it has A and B, like, opposed to M and B, but, like, for A, it shows, like, it does, like, A in the textbook on page 303 is the equation for what your B is on the board.
Right. So remember the first thing I said when we started is that our form looks like y equals mx plus b. So their b is our m, and their a is our b. Right.
Okay.
So their equation is y equals a plus bx, but just imagine ours says y equals b plus mx. So the first equation, yeah. So the first equation up at the top, use that for your y-intercept. And then the one there in the middle, use that for your slope.
Okay, so sorry. Thank you.
No problem. Yeah. 219 summation x to y 124, 600. Yeah, I knew that was going to be like a point of kind of confusion there because they established theirs a little bit differently. So this is set up for B, summation of y, 1713, summation squared, 16303, minus 219 times this right here. And for here, I just said same, because it's going to be the same denominator as it was right here. All right, so I'm seeing some of the same numbers here. And again, if you're working a little slow, that's fine. Just in the interest of time. So at least right, it's looking like a lot of people are getting this here. Keep putting in what you have. So the more I see it repeating, the more confident I guess I'll be on here. But remember, we're saying this times this times this, and then I'm subtracting them. And then I'm going to divide by that number on the bottom. So, okay. So step 2 says calculate the slope and the y-intercept for the regression line. So that's what we just did. We found M and we found B. So that's going to be the end of step 2. But notice how there's so much blood, sweat, and tears that went into finding those numbers there that I don't want you to think that they just popped in from nowhere, right? So you're going to have to be comfortable doing this on the exam. If I give you a problem, can you use these formulas to figure out what these are here? Somebody has a call? Yeah, apparently I do. Sorry about that. Okay.
Professor, I got a completely different answer, and I seem to have plugged in the numbers correctly, so I'm not exactly sure why things are different.
Okay, I can talk about it later one-on-one, but I'm gonna sort of keep going with the class so we can sort of get we have to. But at least write these answers here, and you and I may have to meet one-on-one to see what happened. Okay? But essentially, you're multiplying these, multiplying those, subtracting them, and multiplying this, right? So it may just be like an order of operation thing that's sort of going off. So, at least when you're studying, just make sure you have these numbers there so you can sort of know where they're coming from. Okay. So everybody, so let's do step 3. Jaylene, did you have a question? I saw your mic turn on.
No, I was just going to say that I realized what I did wrong.
Okay, all right. Step 3. Now this is going to be the final step. And so we just did question, I think it was 3 and 4 on the handout. Now step 3 says draw the regression line. Draw the regression line using the M and B values. Draw the regression line using the M and B values. Okay, so we're gonna show us how to do this. In fact, go ahead and write down what you think is the equation of the regression line. We found M and we found B. Write the equation of the regression line. We now have an M and we now have a B, so you should be able to use those values to write the equation of the regression line. Because then from there we got to draw it. What is the regression line? Megan, any idea? I know I'm just calling out the blue, but what do you think the equation of the regression line is?
Is it y equals mx plus b?
Yes. In general, that's what it is. Now, what is it in this specific case? We found M and we found B. What do you think it would look like?
So it'd be y equals 7.41
And then would it be the x value we found earlier?
You're right there. You're right there. That's the I can see the wheels turning. But you're exactly right. And I think you said 41, but it's just kind of switched. So we're gonna write this: y sub l equals, well, what is ordinarily is mx plus b. Well, here's our m, 7.14x, and then what? Plus.
37.08.
There you go. There you go. You see that? You see that? So this is the equation of the regression line. Now it assumes that you found this correctly and that correctly. So that's why when you do the homework for this week, it's going to give you more opportunity to kind of use the formula and figure out where you're going right and going wrong. But yeah, that's the whole point in doing this, because I used the m that I found and put it right here, and I used the b that I found and put it right here. Y equals mx plus b. So this is going to be the line for our specific problem with the foot traffic and the sales. Another question? Well, I guess somebody want to tell me what b was.
What is the L for?
Huh?
What is the L for?
Oh yeah. So this L just simply means that it's a line. Not only is it the line of best fit, but it's going to be a prediction line. So the L just basically stands for linear, like linear.
Oh, okay. Thank
Yeah.
you.
It's going to help us predict. Yeah, very good, Lily. Very good. So now let's draw the regression line, but we have to use this to help us do it. Now, what we're going to do is superimpose it on top of the scatter plot. So go back to your picture, the scatter plot that we did earlier. And I erased it, but oh well. I'm just going to sketch it back. Okay, so let's draw this. Here's our scatter plot. I think we had a point here, here, oh, I don't know, here. I think that's roughly how it looked. So when we draw our regression line, what I'm going to do is choose any two arbitrary x values in the range of our x data. What do I mean by that? Look at the data, the original data. It has foot track as like 29, 49. Look at only that x column. Choose an x point, choose any x point in that range. Oh, I don't know, just type in there. Choose any point, like what's the minimum point? I guess it's 29, I don't know, whatever the minimum and the maximum is. Choose any x value in between there. Just any x value. Does 10 fit? Is 10 in between there? Or no?
No.
Okay, so choose any x value in between that range.
75.
75, okay. So I'm going to choose 75 here. In other words, it's almost like f of x, f of 75. So I'm just putting 75 inside of here. So I'm going to say 7. Let me do it this way. I'm going to change colors so you can see what's going on. 75. So I have 7.14 times 75. Yes?
Can you just explain to me why we're using 75 again? I'm sorry.
So you can choose any value in between the range. Any value.
Okay.
We have to choose two values. And so I'm just telling you to just give me any value as long as it's in between that range. And it sounds like 75 is in that range. What's another one? Can anybody tell me just any other one?
Wait, range of what exactly? Sorry.
In the range of the X values. You see the X values there for foot traffic? You have 29, 49, whatever. So look at the high number and the low number and give me a number in between there. So I said 10 earlier, but I don't think 10 is, I think 10 is outside of that range. What's another number in the range? Any arbitrary number.
40. Would that be in between?
Does 40 work? What's the high number? I forgot. What's the high number of foot traffic?
110.
Oh, yeah.
And what's the low number?
29.
Okay, yes. So both of these are in that range. In other words, it's going to become a problem if you give me 200, because 200 is not in that range.
Okay.
Right? So now this is going to become 7.14 times 40 plus 37.08. Why am I doing this? The reason I'm doing this is because I'm trying to plot this line here on this axis over here. And the simple way to do it is, I know I showed earlier before, start with the y-intercept and like move this way and that way. But in this case here, what I'm trying to simply do is plot two of the points here that I'm going to blue and green, put those 2 points here, and then simply draw the line using those points. But it has to, because I know this is the equation of the line that's going to work, but how do I draw it? I'm choosing two arbitrary x values, and I'm going to see what their y values are. So solve this right here. Put 75 here and solve this right here. Yes.
I'm not sure if you explained this already, but why aren't we using the actual x values but a range instead?
Right. Yeah. Now I could. That's a good question. I could use either one of these 4 points here, like the 29, the 49, and it will be just as valid. But the values that I get from this prediction line are not necessarily going to be the y values that correspond to these particular points here. It's going to be a line somewhere here. So I would be well within my rights if I wanted to choose 49, right? In other words, 49 is not only a point, but it's still in the range of those x values, right? So I could use 49 here. I also could use 29 right here. But you're going to find out if I use 49 or 29 or any value inside of there, it's always going to give me a point that's going to end up on this green line that I want to draw. So I'm not limited only to putting in just these numbers right here, those x values. I can use any x value within that same range of those particular points there. All right, so what is this right here when you find this? What is the y that comes out when you put in 75 here? So you're going to do 7.14 times 75 plus 37.08. 37.08.
I got 572.58.
572.58. Anybody else? Anybody else?
I got the same number.
Same number?
Mm-hmm. Yeah,
All right.
same.
All right. Let's go to this one. Now this time put in 40. You see, this is going to give you a line. And doing this strategy here is going to help us draw the line. Putting in two arbitrary x values as long as they're in the range there. So I guess this should be less than 572. This should be, what, 3 something?
I got 322.68.
Okay. Anybody else? Anybody else get the same thing? Okay, you got the same thing.
Yeah, the same.
Okay, so now on your scatter plot, and again, I don't have, like, we had 25, 50, or whatever. Plot these. 75, and you may want to use a different color. 75, comma, 572.58. That's 1 point. The other one is 40, comma, 322.68. Plot this point and make it like a green X or whatever other color you're using. Plot it as an X, which differentiates it with the actual data point. So you go over 75 and up 572. Oh, I don't know. Mine's not drawn to scale. Let's just say mine is right here or something. Then plot 40, comma 322.68. Oh, I don't know. Maybe it's right here. I apologize. I just really don't have the numbers down here. I had to erase it. But make yours as close as possible, kind of to where they are. And then once you draw those two X's, whatever color you use, then just draw the line as smooth as you can going between those 2 points. And mine may look different than yours, but oh well.
Wait, so to plot them, I'm just like confused because I just got to the step where we got 322.68. So that would be.
So then what you're going to do is plot this point here, the first point that you use, 75, comma this.
So the 75 is x.
Yes.
Okay.
Then you're going to plot this one right here. So we're putting this value in for x, and then what we get out is going to be the y. You're going to plot that, comma that. Yeah. Now this may not look like you're drawing here because I don't know if it's going up here. Yeah, I'm listening.
I got a different number for the 572 and 322.
Okay, what did you get?
I got 592 and 333.
Okay, so type in your calculator 7.14 times 75.
Okay.
Equals
Mm-hmm.
plus 37.08, and let me know what you get.
Okay, I got it now.
Okay. So when you guys plot this, so do an X here and an X there, draw that, and that's called my prediction line. That's the whole point of this particular problem. And again, notice how this line here, if you drew yours correctly, I'm not sure, maybe some of the points should be above the line and maybe a point like underneath the line, if that makes any sense. But it should fit kind of snugly in there somewhere. But notice how it's definitely different than if this green line were like down here. This process forces the line to be as close to all of these dots as close, as close to any other line that you would draw in that particular scenario. Okay. Now I think we're going to hold off on. I think the next class period we're going to get into interpreting what this M and B value are. On the handout, let me see here. Oh, okay. We actually sort of got through the handout. Number 5 and 6 predict sales when the foot traffic is 74. We actually chose 75. That's like putting the 74 in right here. Because now this is called, once you find the regression line, it's also called the prediction line. And when you start putting values in for X here, then you're kind of predicting what you expect the Y to be. So they say predict the sales when foot traffic is 74. You put the 74 inside of there, and whatever the answer is, you say, oh, I predict that the sales will be $572.58. Trick question. What's the answer to the last problem? Be careful.
You can't do that because it's not in the range, right?
Huh?
You can't do the last one because it's not in the range, correct?
Very good. Very good. Because see, some people will think, oh, just slap the 16 inside of X. But remember I told you about before you can get a prediction from the regression line, that X value has to be in the range of those X values. Do you see that? That's a very good observation. Do you see how that 16 is not in the range, right? Because see, the range in this problem goes from 29 to 110, right? That's like the range. So if I ask you about any value that's outside of the range, like 16 or 200, then your answer has to be, we cannot offer a prediction because 16 is outside of the range of the X values. So be really careful about that. Be really careful about that. Really careful about that.